Hello, my name is Cody, and today I will be doing 2009 AP Chemistry Problem-Free Response Question Form B. A student performed an experiment to investigate the decomposition of sodium thiophosphate in acid solution, as represented by the equation above. In each child, the student mixed a different concentration of sodium thiophosphate with hydrochloric acid at a constant temperature and determined the rate of disappearance of the S2O3 2. Data from the 5 trials are given below in the table on the left and are plotted on the graph on the right. The first question asks to identify the independent variable in the experiment. The independent variable is the variable that the student changes. So it says that the student mixed different concentrations of sodium thiophosphate. So your independent variable is going to be your initial concentration. So let's just write that in. Writing's hard. So it's going to be your initial. Then it asks to determine the order of the reaction. To find the order, you're going to do rate 1 or rate 2 over rate 1 is equal to the concentration 1 or the concentration 2 over 1. So when you plug that in, we'll just use the first two to find it. It's going to be 0.030 over 0.020 is equal to 0.075 all over 0.050. So when you solve that, that's equal to 1.5 equal to 1.5, and you're trying to find the order. So x. Divide 1.5 times 1.5, and it's or you could tell by looking, it's a first order reaction because 1.5 to the first power is just 1.5, so it's going to be a first order. The next question is determine the value of the rate constant K for the reaction. Include units in your reaction. Show your work arrived at your answer. Alright. So since this is only involving one compound, we don't have to do a rate law. We can just do the pseudo rate law like you would if you were looking for just one compound. So it's going to be rate equals K concentration. And so you can just use the first one. Your rate is going to be 0.020, and you're just going to divide that, or the units on that are um, molarity per second, and you're going to divide that by 0.050 molarity. So the molarities cancel. All you have left is seconds. So your K is equal to 0.40 seconds to the negative first. Okay. And then the second question is, in another trial, the student mixed 0.10 molarity Na2S2O3 with hydrochloric acid. Calculate the amount of time it would take for the concentration to S2O3 negative 2 drop to 0.02 meters. Well, so you can see, sorry, I had to take a break. So on our green sheet, it gives us the equation. Gotta find it again. ln A T minus ln A initial equals negative KT, and we can manipulate that equation to get ln A T over A initial equals negative KT. We know all of this stuff, so all you have to do is plug in and solve for T. So you're going to have ln of 0.020 molarity on top over 0.10 molarity equals to negative 0.40 seconds to the negative first t. And when you solve, t is equal to 4 seconds. And the final question asks, on the graph above, sketch the line that shows the result that would be expected if the students repeated the five trials at a temperature lower than during the first set of trials. And so the line is going to just start lower on the y-axis, and it's going to have a less steep slope, so it's going to look something like this. Because that with a lower temperature, the rate won't be as high, and they already started. Yeah, the rate of initial rate won't be as high because the initial energy needed to change it won't be there. So it's just going to start off lower and just have a lower slope. And anything below this line with a lower slope would be acceptable. And that is 2009 Form B, question 2.